Good day, sir. This is Jason Embargado, a BECE 3B student, and this is detailed quantity survey for masonry and steel reinforcement, CE40 quantity surveying laboratory. The introduction. Estimating is a technique of calculating or computing the various quantities and the expected expenditure to be incurred on a particular work or project. The following are necessary for preparing an estimate. First is the drawings. Under the drawings are the architectural plan, the plan front, rear, left, and right side views. Typical sections showing masonry walls and partition walls. Schedule of footings, columns, and beams. Plan and sections of slabs and stairs. Then for the number 2, detailed specifications about workmanship and properties of materials. And the objectives. This activity covers the aspects of estimating quantities of the required materials for the select and masonry works in the proposed construction project. At the end of this activity, the students are expected to first is be able to identify the item of works under masonry works item 1046.704 reinforcing steel item 404. Then for the number 2, be able to calculate the required quantities for item 1046 and 7 over 704 and item 404 in the project. For number 3, rules of measurement. All work shall be measured subject to the following tolerance. Linear measurements shall be measured to the nearest 0.01 meter. Area shall be measured to the nearest 0.01 meter squared. Unit weight of steel bars to the nearest 0.01 kilograms. And for the output 1, masonry works item 1046 over 704. From the building plan, this is the front elevation, the right side elevation, the left side elevation, then the back, the rear, the back side. Area fall that was designed in CHB is total area fall from the building plan that is 215.26 square meter. For concrete hollow block using area method, refer to table 2.2. Quantity of cement and sand for CHB mortar per square meter. The number of concrete hollow block equals area of wall that is 215.26 times 12.5 na constant gikan sa table 2.2. So number of concrete hollow blocks is 215.26 times 12.5, that is 2690.75 or say 2691 concrete hollow blocks. Mortar for block laying and filler of 5 concrete hollow block. Refer again to table 2.2 quantity of cement and sand for concrete hollow block mortar per square meter. Use class B mixture 40 kg cement. Then cement, that is area of total area of wall with concrete hollow block. 215.26 times constant nga 1.013 bags. That is, the cement is 216.273. Then for the volume of sand, that is 215.26 square meter times constant nga 0.08438. Then the volume is 18.164 cubic meter of sand. Then for letter C, plaster mortar. Refer to table 2-1 quantity of cement and sand for mortar and plaster mixture per cubic meter. Given hollow block. So hollow block design is 15 centimeter thick and wall thickness is 30 centimeter. Plaster thickness is 15 centimeter and 7.5 cm each side. Use class B mixture 40 kg cement. The volume of plaster is total area, that is 215.26 times plaster thickness, that is 0.075 meter or 7.5 cm. So volume of plaster is 16.1445 cubic meter. For the cement, the volume of that is volume of plaster times 12 bags. That is 12 bags is sa class B mixture 40 kilograms. That is 194 bags. Volume of sand is volume of plaster times 1, that is 16.445 cubic meter. For letter D, wall footing, refer to table 1-2 concrete proportion. From building plan, the total length of wall footing is 31 meter. Width of wall footing is 0.3 meter. Volume of wall footing, that is length times width times thickness. Thickness, that is 0.15 meter. So 31 meter times 0.3 times 0.15, that is. The volume of wall footing is 1.395 cubic meter. Using Class B mixture 40 kilograms cement. Cement equals 1.395 cubic meter times 7.5 bags. That is 11 bags. Cement is 11 bags. Then for the volume of sand, that is 1.395 cubic meter times 0.5, that is 0.6975 cubic meter. For the volume of gravel, 1.395, that is times 1. So volume of gravel is 1.395 cubic meter. That is for the output. Number 1, masonry. Output number 1, masonry works item 1046 over 704. For the output number 2, that is reinforcing steel item for footing reinforcement. This is the diagram. This is my plan, man akong plano. This is the footing. Then the length is 1.5, width is 1.5 square. So clear length is 1.5 minus 0.075 meter. Now clear cover both sides equals, that is equal to 1.35 meter. Then the bend length is 0.4 meter minus yung clear cover nga 0.075 meter minus 0.075 meter, that is equal to 0.25 meter. Then the total cut length niya is 1.6 meter. Total cut bars in one footing, that is 8 times 2 because 8 kabok ang nadari 8, then 8 pod sa yung intersection, that is 8 times 2, that is 16. 16 kabok cut bars sa isa ka footing. At 17 total footing, so 17 kabok footing na ako, same footing lang tanan. So total cut bars is 16 times 17. 16 ka cut bars times sa 17 kabok footing na ako, that is 272 pieces at 1.6 meter long. Then total length of all bar used, that is 272 times 1.6 meter equals 435.2 meter. The most economical cut is by using 5 meter length bar that would result in an excess of 0.125 in comparison to the other commercial length bars which result a large value of excess. Number of cut in every 5 bar is 5 over 1.6, that is 3.125, say 3 cut. So the number of bars needed is 272 divided 3, that is 97 pieces of 16 millimeter 5 meter bar. So this is manigain na 16 kabok, 1, 2, 3, 4, 16 kabok bars. So for the tie wire footing, number of intersections for 17 footings, that is 8 times 8 equals 64 times 17. So 8 times 8, 8 kabok. Sa isa ka footing na ay 64 kabok intersections. So muna siya ang higtan itay nimo. Then sa isa ka footing 64 ka intersection. So naman ko 17 ka footing, so to 64 times 17, that is 1088 ties at 25 cm per tie. Total length of ties, that is 1088 ties times 0.25, that is 272 meter of tie. At 1 kilogram of number 16 group index wire is approximately 53 meter. Total mass of tie wire is 272 over 53, that is 5.132 kilograms of tie wire. So for the column length is 7.8 meters based on the drawing in the previous part. The column length is 7.8 plus 1.5 and 1.5 nga gi-excavate karon sa lalong sa foundation plan, that is 9.3 meters. And the bend length is 16D, and that is 0.256 meters. Total length of main bar is 9.3 plus 0.256 equals 9.556. For main bars, use 10.5 meter nga bara kong gamiton para gamay ra axis. And per nya axis niya is 0.944 meter. For total main bars for one column equals 6 bars at 70 number of columns. So total main bars needed for all columns is 6 times 17, and that is equal to 102 pieces of 16 millimeter 10.5 meter bar. For lateral ties, by inspection, Lateral ties by inspection, the total number of lateral ties. For lateral ties by inspection, the total number of lateral ties is 9.556 over 0.2. Then, plus 1 sa taas. Plus 1 kay 0.2 muna yung mga distansya. So, napa-isa sa taas. Yung edge. So, plus 1 that is 48.78 or say 49 per column. Sa bawat column, na siya ay 49 kabuok ties. Lateral ties. At 17 columns, 49 times 17, that is 833 lateral ties. And the length of one lateral is 1.2, so 833 times 1.2, that is total length of lateral ties. And the total length is 999.6 meters. Use 6-meter commercial length bar. So the total number of bars is 999.6 over 6, and that is 166.6. Say 167 pieces of 10 millimeter. Then atong gamiton nga use commercial nga 6-meter bar. For tie wire sa column, total number of lateral ties is 833 lateral ties. Note, 6 tie wires is needed for one lateral tie, 25 cm per tie wire, 1 kg of number 16 GI wire is approximately 53 meters. So the total length of ties is 833 times 0.25 times 0.6, that is 1249.25 meter. And the total mass of tie wire is 208 over 53. That is equal to 23.575 kilograms of tie wire. Then for the beam reinforcement, beams along row B, C, and D. So this is the beam reinforcement. This is column 1, column 2, column 3, column 4, column 5. This is row B, C, D. Then splice of beam, that is 40 times diameter of bar. So continuous length of bar, that is 15 meters. So gipit lang ako continuous para dali siya calculate. Pero I know expensive siya. So bar na ako diri, assume na ako nga continuous na lang siya para dali ma-calculate. So total length of one bar is 15 meter plus 1.28 meter. Kanang 1.28 is splice sa beam. That is, and total length of bar is 16.28 meter. Use 14 because 7 bars, and then itong gamiton kay 14 kabuk bars. Kaya itong gamiton kay 9 meter nga baraman. 14 times 3, and that is 42 pieces of 16 millimeter 9 meter bar. For intermediate, stipend na 12 millimeter bar. 2 bars, intermediate length of bars is 15 plus 0.96, and that is equal to 15.96 meter. Use 4 times 3, nagduha ka bar sa isa ka linya. Sisumpay na sila. So, napay splice. So, gamitan na ako is 4 times tulo ka buok. This is beam nga along row B, C, and D. So, tulo sila 4 times 3, 12 pieces of 12 millimeter 9 meter bar. For stirrups, 4 beams along row B, C, and D. By inspection, the total number of stirrups is 324 stirrups. So, by inspection, 324 stirrups. And length of one stirrup is 1.6 meter. Then, use 5 meter commercial length bar. Use 5 meter commercial length bar. So, the total length of stirrups is, yung total length of stirrups is 324 times yung length niya 1.6, that is 518.4 meter. Number of cut in every 5 meter bar is equal to 5 over 1.6 equals 3.125, say 3 cut. So number of bars needed is 518.4 over 3 equals 172.8, or say 173 pieces of 10 millimeter 5 meter bar. For tie wire of beam row B, C, and D, total number of stirrups is 324. Then the total length of ties is 324 times 0.25, that is 81 meter. Then the total mass is 81 over 53, and that is 1.528 kilograms of tie wire. Then for the next beam, the beams along column 1, 2, and 3. Splice of beam, same 40 times diameter of bar. So, assume na po na akong continuous length para dali siya makalculate. Then, for continuous, 16mm bar, 7 bars. So, 8 meter. So, ang gamiton is 9 meter nga bar. So, total length of 1 bar is 8 meter plus splice sa beam nga 1.28, that is 9.28. So, use 7 times 3. 7 times 3 beams equals 21 pieces of 16mm 9 meter bar. For intermediate stiffener, 12mm bar, 2 bars, and use 2 times 3 equals 6 pieces of 12mm 9 meter bar. For stirrups, for beams along column 1, 2, and 3. By inspection, the total length of stirrups is 162 stirrups. Then length of one stirrup is 1.6 meter. Then again, use 5 meter commercial length bar. So the total length of stirrups is 162 times 1.6, and that is 259.2 meter. The number of cuts, same. There are 3 cuts, then 259.2 over 3 is 87 pieces of 10mm 5 meter bar. For tie wire of beam along column 1, 2, and 3, total number of stirrups is 162 stirrups. Then total length of ties is 162 I times 0.25, that is 40.5 meter. Then total mass of tie wire 40.5 over 53, that is 0.764 kilograms of tie wire. Then for the next beam along column 4 and column 5, same splice of beam is 40 times diameter of bar. The diameter of bar is 16mm. So, assume nga po na continuous ang length sa bar para dali makalculate. So, continuous length of bar is 11 meters. 11 meters. 4 plus 4 plus 3. Then, total length of bar is 11 meters plus 1.28 nga splice, that is 12.28. So, use 7 times 3 equals 21 pieces of 16mm 12 meter bar. For intermediate stiffener, 12mm bar, 2 bars. Intermediate length of bars is 15 meter plus 0.96. That is, by the way, this is not 15, this is 11 meters plus 0.96. This is 11.96 meters. So we will use 2 times 3 equals 6 pieces nga 12mm 12 meter bar. This is 11.96. For stirrups, for beams, and clarification sir sa kaning bar dere 12.28. So kulang ni siya nga kulang ning 12 meter. So again, piliw na ko tong kwan. Dapat tagduha ka bar akong gamiton. So 12 man siya. Dapat magamit ko taas-taas nga bar. So clarification sa sir na sipyat ani. So ako na siyang edit sir. Then for stirrups, for beams along row 4 and 5, by inspection the total number of stirrups is 160 stirrups. Length of one stirrup is 1.6 meter. Then again, use 5 meter commercial length bar. So total length of stirrups is 256 meter, and the number of cuts, say 3 cut, and the number of bars needed is 86 pieces of 10mm 5 meter bar. For the tie wire in along row 4 and 5, there are 160 stirrups, and the total length of ties is 160 times 0.25, that is 40 meters, and the total mass of tie wire is 0.7547 kilograms of tie wire. For beams along row A, so same splice of beam is 40 times diameter of bar, mga 16mm. Then assume again nga continuous ang length of bars. So continuous length of bars. For beams along row A, so continuous length of bars is 5 meter. Then for continuous length, 16mm nga bar, pito ka bar ang magamit. So total length of one bar is 5 meter plus Kaya supply sa beam nga 1.28, that is 6.28 meters. So use 6 times 3, 18 pieces of 16 millimeter. Akong gamiton nga bar is 7.5 meter bar. For intermediate stiffener, 12 millimeter bar, 2 bars, so 2 times 3, 6 pieces of 12 millimeter, mga 6 meter nga bar. By inspection, the total number of stirrups is 27 stirrups and length of one stirrup is 1.6. So the total length of stirrups is 27 times 1.6, that is 43.2 meter. Number of cut in every 5 meter bar is equal 5 over 1.6, and that is equal to 3 cut. Number of bars needed is 15 pieces of 10 millimeter 5 meter bar. For tie wire of beam along row A, so the total number of stirrups is 27. So total length of ties is 27 times 0.25, that is 6.75 meter. And the total mass is 6.75 over 53, that is 0.127 kilograms of tie wire. For the letter D, the slab reinforcement. So akong first floor ug second floor kay same ra silang slab kay akong hagdanan kay naman sa gawas. So the area of the two floors is 266.94 square meter. Referring to table 3-8 quantitative steel bars and the wires in one-way reinforced concrete slab, use 5 meter bars at 150 millimeter spacing. So the number of bars is 266.94 ngayang area times 3.524, that is 940.7, or say 941 pieces of 13 millimeter nga 5 bar. Use 5 bar. Use 25 cm per tire wire. So tire wire is 266.94 times 0.163, that is 43.51 kilogram of tie wire. So for letter E, for the wall reinforcement area method. So gikan gina sa masonry atong total sa concrete hollow blocks is 2691 CHB concrete hollow blocks. So refer to table 3-4. Length of steel reinforcement for concrete hollow blocks work. For vertical reinforcement at 0.80 meter spacing, OC. Total length of steel reinforcement is 2691 times 0.128 nga constant sa table. That is 344.448 meter. Use 10 millimeter 5 meter bar. Then the number of bars is 344.448 over 5, that is 70 pieces of 10 millimeter 5 meter bar. And for horizontal reinforcement at every 3 layers of concrete hollow block, total length of steel reinforcement is 2691 times 0.172 nga constant, that is 462.852 meter. Again, use 10 millimeter 5 meter bar. So the number of bars is 93 pieces of 10 millimeter 5 meter bar. And for tie wire, refer to table 3-5 kilogram of number 16 tie wire of concrete hollow block reinforcement at 0.80 vertical spacing every 3 layers of concrete hollow block, 25 cm tie wire. Tie wire is 0.0016 nga constant, that is 4.3056 kilogram of tie wire. And that's all for masonry. And the reference is simplified estimate by Max Fajardo. That's all for today. This is detailed quantity survey masonry and steel reinforcement. Activity 2C, Jason Embergado reporting. Thank you. God bless.